Okay, we're happy to welcome back to Speaking of Data for his next appearance, James Kobielus. Welcome, Jim. Thank you so much for returning. How are you today?
I'm doing good. Andrew.
Good, good. We're going to get right into it today. We're going to be discussing DataOps and MLOps pipelines. And I think a great place to start is, if you could, maybe share kind of a baseline understanding of what those two aspects are, and really the integration of these two things is what we're going to talk about as well. So if you can kind of maybe set the stage for everybody and explain a little bit more in depth, that would be great.
Sure. When you look at modern applications, they involve particular elements that need to be combined and engineered and modeled and built and deployed in a unified fashion to stand up high quality applications. And when I'm talking about these elements or artifacts, they are data, they are machine learning models, but they're also things like program code and APIs and so forth. When you look at then the modern state of the art for building high quality applications, then we look at really streams of work that need to operate in parallel and rely on common platforms, infrastructure, tooling, and really a common workflow. And so there's data, and really data, of course, is a core aspect of things like machine learning models, which are a core aspect, are element of artificial intelligence. So data engineering is all the processes from discovering the data, ingesting it into your environment, doing profiling of the data, looking for quality and format and so forth, being able to transform the data to some standard or other format that you need to process going forward that data in, cleansing the data, correlating, consolidating it, and then so forth. Then that's data ops, data engineering. Data ops refers to a set of practices for that end-to-end workflow of preparing data for incorporation into and deployment of applications, intelligent applications, on the one hand. Then there's models, machine learning models, analytical models, the entire set of processes from building the models to training them, deploying and testing and measuring their performance, and then iterating on the training and deployment and measurement until you get the models exactly right. And the models themselves are built on data. That's MLOps. MLOps is short really from machine learning optimization. You can call it model ops more generally. Same phenomenon. So data ops and MLOps is all about preparing the data and the models that you build into your intelligent applications, such as the conversational digital assistants that are built into mobile devices, edge devices, and you name it. So those are both workflows that depend on a core set of infrastructure and tools, and really a core sort of frame of reference for defining what human beings need to be involved in this process, as well as what degrees of automation are necessary to prepare each of these elements in parallel, but also to combine them into a unified application for release under practices that are often known as DevOps, the continuous integration and continuous deployment, and so forth. So we're talking about really increasingly a key trend that TDWI has been seeing is the unification of data ops and MLOps processes and pipelines. And the term pipeline refers both to the platforms that are supporting all these capabilities, but also to the workflows, the structured workflows that are necessary to do it all. So that's what we're talking about, integrating of data ops and MLOps pipelines in this new world of intelligent applications to enable intelligent applications to be built faster and of higher quality and more scalably to keep pace with the dizzying, dynamic nature of the modern business world.
Yeah, absolutely. I think that was a fantastic definition. And even for someone like myself, who I'm certainly not a subject matter expert, was able to follow along there. So, the next question is, you kind of just touched on it there. Let's unify these pipelines. We got the data ops, we got the ML ops. Let's allow them to work together. So what would be the justification for a business to want to do something like this?
Right. To build more rapidly and more efficiently, more intelligent applications of all sorts. Of course, to deliver to customers, to deliver internally to your employees, and in your, to enable your supply chain to operate more efficiently and so forth. And so really the business case for the unification of DataOps and MLOps pipelines is really grounded on a number of things that enterprises can measure and have a clear relevance to their bottom line. One of which is, to cut the average time needed to train ML models for deployment. If you can acquire the data needed to build and train these models faster, if you can cleanse and consolidate the data more rapidly, and to ensure that the data is of a higher quality. If you can build and train the models more rapidly and deploy them into the field for testing and iterate through models more rapidly to fit the models for their intended applications, then that means you can shorten the time to value on your investment in AI or in advanced analytics as deployed into the business. So, there's increasing or shortening the time to value for intelligent applications, but also being able to scale up the number of data-intensive analytical ML and other models, to scale that up so you can be deploying more analytic models more rapidly and iterating through them and improving them more rapidly. Really, scalability is a key metric here in terms of business runs on intelligent applications. And increasingly, as intelligent applications are deployed everywhere, scalability is absolutely essential, and integration of MLOps and DataOps enables a higher degree of automation in that process. So really, when you look at what we've done in our research, so when we talk to enterprises that have integrated these pipelines, they can basically not only speed time to value for these applications and deploy them more scalably, they can do it in a more automated way that takes the burden off of their data scientists and data engineers to do fairly mundane, low-level tasks, so they can be working on higher value tasks to build new applications in creative new ways. So there's a productivity angle, a human productivity angle to the business case for unification of these pipelines.
I was going to follow up and ask, if you could name or list a few priority use cases to give concrete examples for organizations that may already be trying to implement this unification on their side.
Yeah, when you look at the priority use cases for unification of DataOps and MLOps pipelines, one good place to start is the notion of a democratized data science capability. As enterprises rely on business users, subject matter experts, analysts who are focused on a particular domain like marketing or human resources or finance or supply chain, for them, increasingly, our people in business are being taking on more data science related responsibilities, so they have self-service tooling that enables them to explore data and to build models and deploy them into production more rapidly, to be able to do more innovative things in business, to productize data more effectively. So really, a core use case for DataOps MLOps pipeline unification is that by unifying these pipelines, you're able to automate more of the back end functions, to take the burden off the actual developer, meaning now increasingly a business subject matter expert. They don't have to, these experts, these domain experts, as we say, don't themselves need to be data scientists, don't need to be data engineers, but they can essentially, through their front-end tooling, highly no-code and visual, they can define the business outcomes they're trying to achieve with intelligent applications. And then they can automate more of the back-end functions needed to prepare the data and the models for deployment, for testing, for training, and so forth. If we're able to speed up, as an enterprise, if we're able to speed up the development of innovative applications of data and machine learning models and the like, that really creates an innovation opportunity to disrupt your business. Because the people with the actual ideas who know how the business works, who owns the outcomes, can actually build high quality applications of data and analytics more rapidly. And so what we see in business is that this is what I'm describing here. The automation of the pipeline plus the self-service no-code visual front-end tools used by domain experts. These are key elements of data as a product, as a new paradigm for modern business. Because data is the heart of most businesses now. And now we're increasingly giving actual domain experts in the business areas the tools they need to stand up and create and deploy these applications themselves. So the unified pipeline is absolutely essential to simplify the back end that's needed to make this degree of to enable these new generation makers or creators to do their jobs more effectively.
That makes a lot of sense. I mean, time is money is the old saying, right? And so
Right.
in an instance like this, you're able to gain more valuable time for those people. Okay, so we know what these things are now, these pipelines. We know that they can be unified. How can they be unified? What's the best, most optimal implementation approach for unifying data ops and MLOps pipelines?
That's a good question. So when we look at the back-end infrastructure of data and analytical models and the like, in most organizations, there's a degree of centralization and decentralization of these back-end infrastructures. To the extent that your organization has centralized its data environment, let's say for analytics onto a data warehouse that serves as the core repository of reference data for all manner of analytic and other applications. And likewise, to the extent that your organization has centralized your data science processes on a back-end data lake, which handles the unstructured data, supports interactive exploration and modeling of the data, and so forth. To the extent that the back-end data and processing platforms have been centralized, then the optimal implementation approach for pipeline integration is to basically converge these investments, meaning to provide a degree of integration between your existing data warehouse and data lake in an architecture that's often called a data lakehouse, so that you can, on the one hand, basically all the data you need for your machine learning processes, most of the core data should be master data should be running in your data warehousing environment. Likewise, most of the core machine learning models and other analytic models you need in business should be running in conjunction with or integrated with your data lake environment. So by implementing a data lakehouse and providing that infrastructure with a common set of tools for data and model governance, for searching and curation of data and machine learning and metadata and so forth. The extent that you've combined those infrastructures into a unified infrastructure with unified tooling to stand up high quality data and high quality machine learning models in a unified way, that should be your start. If you have a highly centralized environment, if you have a highly decentralized environment in terms of data management and machine learning and data science, one key thing you need to do in that alternate scenario is you need to have a degree of a unification of all these assets behind an abstraction layer that enables you to query data in a uniform, simplified way across all these disparate environments, but also an abstraction layer that enables you to program machine learning models in a unified way using a high-level abstraction layer that enables then, once you've built a once you've specified how to build a machine learning model for a particular task, that the backend infrastructure will then compile that code and execute it on the optimal backend platform within the pipeline. So that latter scenario calls for a virtualization layer that essentially unifies the process of handling both the data and the machine learning models, and really enabling you then to whatever whether you're writing your machine learning models in Python or in in R or some other language, enables you to, in a unified way, to find all the data you'll need to build and train those models without you yourself having to specify the specific location where that data may be resident. The infrastructure, by leveraging such investments as a data catalog, will find that data for you and manage the various versions of both the data and the machine learning models you build for deployment into a production environment. So when we're looking at different enterprises, there are different degrees of centralization versus decentralization in their legacy data and machine learning environments. And then you should build the infrastructure needed to provide, in either case, to have a unified access and view and programming of all the relevant assets, so that you can then deploy ultimately your data intensive machine learning applications in a unified way and monitor through observability tools the progress that these models have made in terms of where they've been deployed, how often they've been updated, to what extent model drift has necessitated a retraining of the model and a redeployment. So you can unify the management of all these assets in production in a unified way. But once again, it's an issue of centralization versus decentralization currently. And also it's an issue of the extent to which, if you have a decentralized environment, does it make sense in terms of data and analytics? Does it make sense to consolidate all of that in a single platform going forward? The consolidation scenario as a migration can take quite a long time. It can take a year or more to consolidate these legacy investments. Is it worth your while to do that? I mean, is there a business case? Do you have the funding, the budget needed to do that exploration? Many organizations can't do that, or at least do that consolidation very rapidly if consolidation is called for. So the notion of a virtualized, abstracted, decentralized mesh environment is coming into more enterprises' planning horizons. And that's a key enabler, that data mesh architecture, for any number of pipeline unification scenarios that might make sense. But it really depends on where you're starting on the decentralization versus centralization spectrum. So there you go.
Fantastic. Yeah, I think that was really thorough. And what we've seen, just in doing this podcast, I've seen research supporting the fact that there's many organizations that are centralized as well as decentralized. So I think that's a whole lot of consideration to take there. So one final question for you, Jim, before I let you go here. You've kind of set the stage on how to execute this and identifying what you need. But in order to have success, let's say you've already identified that you're centralized and you followed the steps that you just outlined. What then after the fact do you need to make sure that it continues to succeed as far as platform tooling or human resource investments?
Right. And let me answer this question by starting at the very business level. Well, what do you need to succeed with your data and machine learning pipeline environment? Well, success in the business bottom line is, to what extent can you build more monetizable data and analytics more rapidly? Monetization in many ways is the essence of being in business. So to the extent that you can empower data product managers with the tools needed to build and deploy and sell, and achieve a revenue impact from selling more intelligent applications more rapidly to more customers, that's the essence of business success in this new world. So when we look at data monetization, then it comes down to increasingly data as a product. Are you empowering data product managers with the ability to both design these products using these tools, as well as to then, as it were, push the proverbial button in order to fetch the data and build the models and train them and deploy them, and then ultimately to be able to find a market for those data products rapidly, and thereby provide the revenues needed to fund an ongoing unified DataOps and MLOps pipeline. Now that I've put it at that level, so what we're talking about here increasingly is business success then depends on your ability to automate all of this. So there's the automation that has to happen in the back-end infrastructure on the data engineering and the machine learning operations pipeline. There's also what we call augmentation. These tools, these no-code and visual tools, enable the data product managers of the world, the data scientists, the subject matter experts to use tools that are suited to their particular skill sets to enable them to augment their own productivity in managing these various pipeline processes, such as the necessary governance needed to keep data fit. There's also the acceleration benefits of having a unified, automated DataOps and MLOps pipeline. To the extent that you have a pipeline that is running on a real-time, low latency streaming backbone that enables all these processes to be handled more instantaneously than in the older traditional batch processing environments. So I sketched out automation, augmentation, and acceleration as key enablers for success. But also I want to point out that going forward in a data as a product paradigm, what you need channels for finding a marketplace for your products. And cloud data marketplaces are coming along fast and furious as a place where data products or data itself or pre-trained machine learning models are increasingly being sold or licensed to customers who increasingly will be coming to these marketplaces to find both the finished data products that they need for their, whatever they're trying to do, but also will find the essential elements like raw data sets or curated data sets that they need for various reasons. So what we see as key to the success of data ops and MLOps pipeline unification is the ability to find a market for the end product from these unified pipelines. Cloud data marketplaces, data exchanges, online communities, whatever you want to call them, are key places where the fruits of these pipelines are provided to hopefully a large and growing market of potential customers. And in order to ensure that the data products being sold through these marketplaces are of sufficient quality, increasingly what we need, what enterprises need, is to rely on data marketplaces that enforce the necessary governance controls on the quality of the data in the models. So data governance, data cleansing, master data management, data compliance capabilities need to be baked into the very processes that are executed within these marketplaces. Because ultimately, when customers are paying good money for a data product, that you need to be providing them with some assurance that you've used due diligence and all the necessary back-end automated processes to ensure that what we are selling them is of high quality, is of the quality as advertised and expected by the customers. So a lot of really back-end controls need to be executed on the pipeline products that are sold through these marketplaces. So really, in many ways, the data marketplaces are a key aspect of the success of any enterprise data engineering ML ops unification scenario that aims to build products that ultimately will impact the enterprise bottom line in a positive way. And so really, the unified pipeline is the sort of the unsung hero of this process. I mean, this is just back-end, highly technical processes that need to be automated and can increasingly be automated to the nth degree. So automation is actually essential. Some of these processes, like in MLOps, feature engineering traditionally has been a highly manually intensive process. Is in terms of the experts, the data scientists, trying to identify the features, the predictive features in the data that are essential for a highly performant machine learning model. Even these are being automated to a great degree now. So fundamentally then, when we look at integrating DataOps and MLOps pipelines, it's a matter of not just integrating the pipelines, but integrating and automating them in a way that's highly adaptable and to new challenges in terms of new types of models that we might build and deploy for monetizable applications. Models like large language models, like the one that's underlying ChatGPT, are coming along in this scenario as well. Now, that is a whole nother talk in terms of pipelines for LLMs like that, because
Yeah.
that's a new world, but it ultimately, as LLMs come to market within the enterprise in a more production way, these same controls of automation, augmentation, and acceleration will need to be implemented in them as well. And likewise, the fruits of these pipelines, in terms of like these chatbots, will also be sold in online marketplaces. So once again, this is a never-ending process of improvement and iteration over time to get these pipelines fit for the next generation of machine learning and intelligent applications. So
Very interesting.
that's all I can say.
Yeah, I would say, you kind of bled into another podcast where we could definitely delve into the data marketplaces. That may be a topic for another day for us here, Jim. But I really do appreciate you coming on and explaining this. I think it was a fantastic podcast. Thank you so much for your time today. Any research that you'd like to call out for people to delve deeper into this topic that they might be able to find on TDWI?
Yeah, we've had 2 best practices reports over the past 2 years authored by myself. One last year was on this exact topic, the unification of DataOps and MLOps pipelines. And we did a primary research survey of practitioners and sketched out the trends in the marketplace that we saw. And just recently, we published my BPR on data monetization practices. Related to all of this, data as a product and automation, and pipeline automation is a big part of it, but also talking about the adoption of cloud data marketplaces as a key channel now. In really the final, the last mile in the pipeline is the pipeline from your enterprise to your customer, and the intelligent applications that flow out through it to your customer, and hopefully make your customer a success as well. So we are very proud of this research. It's high quality, and these are addressing key trends we're seeing in the enterprise everywhere, all over the world.
Fantastic. Well, thanks again, Jim. And for our audience members, please go check that out. You can find that at tdwi.org under our resources and research tab. Again, Jim, thank you so much for your time. We'll let you go. Have a good rest of your day. Okay.
Okay. Take care, Andrew. Bye.
Thanks. Bye-bye.